Yeah. Hey everyone, now we've got Sergio and Pei here, so we want to have a basic touch on what is Arduino. And I've been using Arduino for a while, and the reason that we decided to use so is because we need to use them for monitoring environmental sensors. You can buy dart loggers, they are on the market, but the problem is that they are too expensive. So we just simply try to, I've been using open source software for a while, and I think that there must be something like open source hardware, and it turns out Arduino is the starting up of open source hardware. And it shares a lot of similarities that the open source field means when you start off using it, you can do everything. But at the same time, you need to take responsibility of all the problems you have encountered so far. So same thing for the hardware. So if you actually have a better understanding of what hardware works, you will have a better idea of what is the way to find out the bugs. But it's not that difficult as long as you have several experience-based project. And these days, the hardware has been done in a way similar to the modules in any programming language. They give you the input and they produce the output. That's exactly what you want. So you don't have to go to a lot of complexities, but it has to be physically linked rather than using the function that transfer the variables across different things. So that's basically the difference between hardware and software. Here we've got quite a few different type of Arduinos. So we've got Arduino Nano. This is a standard type of Arduino. It has relatively less number of pins. It could supply power from the USB. It could also supply the power from the barrel jack here. So this is another type of Arduino. So you've got a lot more pins here. And again, you also got the USB connection and the barrel connection. So the barrel connection was declared that it is able to step down from 5 volt to 12 volt, from 5 volt to 12 volt to the 5 volt. But what I found is that this got a linear voltage system, right? If you provide 12 volt for a long time, this guy is going to burn out. So never try to use 12 volt or above to supply power for the Arduino. Okay, so now what really happens on this board is that it's going to be powered by USB, and then the USB signal will be converted to serial signal through a converter called FTDI. So that's where you are able to power the Arduino plus programming it, right? Aside from that, you've got a lot of pins here. I want to just quickly show what does each pin mean here. So let's go from here. So you've got the reset. The reset pin means that if you put this pin to the ground, the whole thing will be reset. The 3.3 volt is to provide power for any sensors that require 3.3 volt. We also got the 5 volt input here to supply power for any sensors that require 5 volt. And ground is everywhere. So you see a lot of ground. So ground here, ground there, and a few other grounds there, and another ground here. Basically, all the sensors, the other side of the pin needs to connect it to the ground. Aside from ground, you also have got the VIN. So what VIN do is that if you provide 9 volt from here, VIN is the input of the voltage, so that would be 5 volt. But the output 5 volt here still provides you 5 volt. Yeah, so that's actually give you a variation of voltage for the sensors, because a lot of sensors have different voltage requirements. Now, talking about one thing, A0. So these analog pins is to measure the analog signals from the sensor. So what does analog here mean is that it's similar to multimeter. So if you use a multimeter to measure voltage, they will tell you 3.3. They will tell you 5 volt. But the analog is in the same way, but it shows a digital number. So if it's 5 volt, it's actually 1024. If it's 0 volt, it's 0. And so if it's 2.5 volt, they give you 512. So that's actually what the analog pins mean. So it's the same as the multimeter. And honestly, the majority of the sensors are designed for analog reading. So it's basically to measure the output voltage associated with something. So if you got an oxygen sensor, they will tell you that if the oxygen is 100%, it's 5 volt. If the voltage is 0, then it gives you a 0. So that's basically the analog. One extra thing that I have to tell you is that a lot of people like to use Raspberry Pi because the Raspberry Pi is able to provide you with a Linux operating system for you to program. That's fantastic. But one thing bear in mind is that Raspberry Pi does not have an ADC chip. What does ADC chip mean is that it is able to measure voltage difference. So if you try to measure voltage difference using a Raspberry Pi, sorry, this is not the functionality. You have to use Arduino. After that, you've got a lot of A's, A8, A9, quite a lot of A's and a lot of numbers. Those are the digital input and output. So in terms of digital input and output, how to understand that? Digital input means that you try to receive strings from there. So let's say you've got a sensor. Sensor is able to measure the temperature, and the temperature is 35 degrees. But the output is going to be displayed as a string, right? So you need to allow the system be able to tell you this is a string. So you need to parse the string. So that's slightly different as compared to the analog. So analog is give you a voltage. So there is literally no 0 and 1, this kind of digital thing coming in. But analog actually sends the 0 and 1, and you need to parse that. That's basically the difference between the analog and the digital. Aside from that is that you are able to do analog output. What does it mean? Sorry, serial like digital output. Digital output is actually to switch on and switch off something. So let's say now you need to switch on a motor. What you can do is that you provide 5 volt to the A10 so that the voltage at this port is going to increase up to 5 volt, and you are able to provide power for a motor or whatever. So you actually can program that. So that's basically all of this. So we've already done quite a bit. The RX and TX is the serial connection. So serial communication is quite common for a lot of devices like scales, and even the Arduino connection to the computer is actually serial. And you've got a lot of PWM. So the PWM has got a special functionality. They are able to send square waves. So the square wave, if you look at the frequency, you can adjust the frequency directly from the program. So that's that simple. And that's basically what the Arduino got the functionality. Now it's a matter of see how Arduino is able to be communicate or programmed to do some simple work. We could first test the analog pins. So currently it's the empty Arduino. There is nothing being connected. So now I already got a Arduino well connected to a computer, and which is the reason why you got the leads on, right? The lead is on. Then we can write a simple program, and then we are able to see how it worked. So for the simple program, this is the Arduino interface. I think the view is pretty good. Yeah. This is a Arduino programming interface, and when you open that, the first thing to check is which is the Arduino located. So as you can see here, port number 9 is already being found as a Arduino Mega. Yeah, so that's basically the port that you need to communicate to, rather than port 3 here. So port 3 is not connected to anything. So you connect to port 9. And the next thing to do is to make sure what type of processors you're trying to build. So currently we are using our Arduino Mega like this, right? So you need to give the right type of Arduino to it. So I need to specify this is Arduino Mega. Whereas if I use a board like this, I need to specify it as Arduino Uno. So you need to talk to the right processor, right? Okay, so if you click this two, then it's pretty much ready to do something. Now let's try to put in a very, very simple example. So basics, analog reading serial, yeah? So analog reading serial has got a template, so those are the comments which we don't have to examine. What we need to see is basically set up the two loops. So you've got setup loops, you also got the loop setup. So setup loop is what will happen before they go to the endless loop. That's basically the initialization of the program. So what we have here is serial begin 9600. That actually means that the USB is going to start the communication to the Arduino. So this is basically, you need to put in that to able to receive some output from Arduino. Then what do you have? This is loop. So this loop will go endlessly. So the first thing is that you define an integer called sensor value. What the sensor value is analog read, that reads from A0. So where are the A0? If you go back to the Arduino, you see analog in, that got A0. That's exactly which pin is going to read, right? And then what they do is that they print out the result to the serial port. And after that, they delay for 1 millisecond. So if it's 1 millisecond, that means in 1 second, it got 1000 reading, and that's too much. What we can do is basically change it to, let's say, 2 seconds, which is 2000, right? Now, you got everything, and you save it. And then, because it's read-only, we need to save it to something in another folder, because it comes from a example, so it's done saving. And then you burn the script into Arduino firmware. So it says that it's compiling the sketch into an executional file. And once that is done, you'll be able to see that this communication pin started flashing once it's uploading. So this is still compiled sketch, and it's not finished yet.
One question.
Yeah.
Is this the only value that we have?
I'll show you what happens. So this is actually the frequency for you to communicate over serial. So it's 9600 bit per second. And we need to first compile the sketch, and then I'll show you how you change it.
Okay.
So now you see it's start of receiving some information. So the script is going to be uploaded, and then it's done uploading. So that actually means the uploading is successful. Now we can check the result. So the check result is going to be in the top left, top right. It's a magnifier. So you click that, you'll be able to see some numbers pop out. So now it's got 435.
But it has nothing. So it's just
it has nothing. But you know, this is
noise.
It's actually the ambient noise. Noise. But what you can do is, see, we've got A0, right?
All right.
We put the A0 to the 5 volt.
So
what happens? It's going to be a constant value, 1024. That's 5 volt. That means it's reading of 5 volts.
Okay.
Yeah. Whereas if we put ground, what does it mean ground? It's 0
So this is the saturation value.
That's the saturation value. Yes.
Okay.
Yes.
So this is 1 bit, all ones.
Yes.
1
yes.
byte, sorry.
1 byte. Yeah. So then if you put them to the ground,
it's 0.
It gives you 0. So I can't see from the screen, so it gives you 0. That's 0.
And let's put it to the 3.5.
Okay, so if we put 3.3.
3.3, yeah.
Yeah. 663. Okay.
All right, okay.
It's a lot of fun now, right?
Got it,
okay, you got it.
All right.
You got it. This is actually the only script you need to use. So now you see that it's very important to know what type of signal does the sensor speak. I would say that majority of the sensor in the world is using analog. Mm-hmm. But then it's a matter of yourself to find out what type of, what does this electrical value mean? So you need to do a proper calibration to understand how much weight it is actually associated with the analog. Right, so that's a kind of calibrations. Okay. Yeah. And what else you can try to do? There are quite a few of the examples you can do. Say, we can do an open recent, say examples. Let's say basics, you got a blink, right? And what the blink means is that it will put the blink, the blink is actually the tiny little lid here, right? That is associated with the lid building lid as an output, right? Yeah. That's the setup. You need to set up this is the output, not an input. And then you're able to say, write this one as high, which means it's 5 volt. And then delay for 1 second, and then change it to low. So if we burn that script inside, you'll be able to see that blinks every second.
Okay.
right? That's basically the thing that you need
So
to...
low is turned off.
Yes.
Okay.
Yes. Okay, now it's uploading much quicker. So now I think it's the right time. You see it's blinking.
Okay, let's put it faster. Let's put
Okay.
every half second or something. Like
Half second, let's say
500.
200, yeah?
Okay.
Well, my daughter likes this.
Ah. Yeah.
Of course. What she did is that she's able to put a line of light bulbs and then try to give a regulation or like a sequence of how it shows displays or not display. So now it's showing much faster. Yeah? Okay?
Okay.
Yeah.
But now the setup is different than in the previous example. The setup has some...
Okay, so remember that in the past what we did is to look at the analog.
Yes.
That's the analog reading.
Yeah.
But this is actually the digital, and this digital is for output. Remember, we just mentioned in the first place, once it goes to output, what will happen is that once it's high, that tells you provide 5 volt to some machine, let's say a motor or a lid or whatever. If you put low, the voltage in that pin is going to be 0. Yeah. So that once it's input, once the digital pin is considered as input, what does it do? It waits for strings. So it converts the 0 and 1, the digital signal, into the input. So that's basically the way.
Okay, and in this case, you set the output as the LED.
Yes.
Okay.
So you can change. LED is actually intrinsically 13. So now if I got a voltmeter and measuring the voltage from that point, it actually goes up and down 5 volt 0, 5 0, 0, 5 volt 0, 5 volt 0. Another interesting thing is that what if you don't want 5 volt, you want to do 2.5? The way how it does is actually PWM. So again, we discussed that PWM provides you a square wave. But if the effective value of a square wave sequence is equivalent to 2.5, that's actually the way how you provide 2.5 rather than 3 volts as an output. That's basically what you can do. So you see, the community has got quite strong libraries to do whatever type of language they speak. So once it comes to digital, it receives string. But the string, the 0 and 1s can be spoken in different ways. It's like people use mouse to speak language, but they can speak Chinese, they can speak Spanish, and they can speak English, and then they need to understand each other. And this is what we call an interface. And so you need to find out a particular sensor, if they are digital, what type of language they speak. Okay. But if it's a language, then we should be able to have a library to parse it, so it should be quite available. Yeah. So in general, this is good enough to start off any simple project and the basic understanding about Arduino. I can also talk a bit more about the difference between Arduino and the Raspberry Pi. So a lot of people were thinking that Arduino is very simple. You know, it's just building a firmware and is able to read something. But that's not always the most reliable way, because what will happen for the digital, for a system that has got an operating system, like your mobile phone, sometimes your mobile phone doesn't try to connect to the internet at all. And what do you have to do? You have to reboot the computer. Mm-hmm. But can you have to go there to switch it off and switch it back on. Can you do that if you deploy something in the moon? You can't. So that actually means this type of simple system is very straightforward. So you just put the power and they do whatever. And you can just plug it off like this. And you plug back on, they on track. They are initializing, but they are start off beeping very soon.
Okay. All right.
Why they are not doing that? There you go.
There you go.
Yeah.
Okay.
So it's really like the heart for a toy. A toy does not need to boot. You just need to put the battery and then they do the rest for you, right? So that's actually Arduino. But for Raspberry Pi, you can do a lot of Python things. You can let them think and even do some analysis. But at the same time, they sometimes freeze, and then you have to physically switch off. So if some of the project you work together, different things, you are able to achieve better results.
Okay.
Yeah.
But with Arduino, you need the laptop, whereas with Raspberry Pi, you don't need a laptop.
Yes and no. Okay. So if you really want to make this one as a standalone, unfortunately, there is no memory inside. Yeah. So you actually have to have a separate module to be able to record the data. The second way is that you see once we switch on the serial monitor, it comes with all the data. So these data are actually already saved in the computer. Yeah. So that's the second way you can save it. So So yeah, so basically you could add a storage component, write it to the storage, or you directly connect to the computer or a Raspberry Pi to record it over time. So it's all up to you. And actually, for open source world, what happens is forking, right? Because everyone has got the core component, and then they're trying to make something of their own. And in fact, if you go for eBay or Taobao or whatever, you will find an Arduino that comes with in-building storage there. So you don't have to do anything. They have already considered that for you, right? And it's available on the shelf.
All right.
Yeah. Is that all? All good? Okay.
Excellent. I will play.